All right, so I'm going to take a second here and come back to the present. So that was 1782-83, where we associated respiration and combustion. We assumed that oxygen and the carbon in the food that we eat was able to meet and combust, and that supplied our body heat and other energy, as we'll later get into. That the other energy stuff really doesn't come up until the 1800s. As far as I could tell, it doesn't primarily. Nutritional calories don't come in until the 1800s. This is just heat transfer, and respiration is combustion. Calories don't come in until 1789, and then they are not defined as respiration, and respiration is not defining combustion in the same book that calories are defined first. In the modern day, the oxygen you breathe and the food you eat do not come in contact with each other. They do not ever, and so it cannot be combustion. We could talk about like a net combustion, but come on, it like hydrogen batteries are not combustion, but they have net hydrogen combustion. So we need to be specific with our definitions. A combustion is a chain reaction event where the reaction of one stimulates the reaction of the next, and the combustion stops when that chain reaction stops. You move by electrochemical dynamics. So the carbon you eat is converted into an acetyl group, which is just a 2-carbon group. And remember that all atoms have potential energy because of the electron orbiting them. Like all atoms are moving and vibrating, like all molecules are moving and vibrating. We didn't know that until the 1900s. Remember, respiration is combustion. That was 1782. Like these things don't line up. So the food you eat becomes acetyl, a 2-carbon group. That starts off in the Krebs cycle, the TCA cycle, the citric acid cycle, whatever you want to talk. Remember, mitochondria, powerhouse of the cell. This one breaks down the carbon of the food that you eat. It's an anaerobic process. Oxygen is not used in that process at all. It's enzymes that break it down. Even some water. Sometimes it produces the water and reuses it right back. But no oxygen. The oxygen you breathe is not transferred into that process to be used with the carbon to decombust it for energy. Okay, it creates cofactors, and they donate like protons and electrons, and those are used for energy. And then in the electron transport chain in a different system, there's a gradient. There's positive hydrogen ions built up in the top, and the electrons transfer across. And in the last channel, hydrogen ions can come through, and it can turn a motor. And that motor brings together the adenosine, the phosphate that ATP needs to restore itself. If it's uncoupled, then it restores body heat and does not restore ATP. They're two separate processes. Sorry, phone battery dying. But yeah, so it's not combustion. Oxygen and carbon never meet.